Hello, in this video we are going to go over the solution of the problem 1302, deepest leaves sum, and we are going to use BFS. Imagine that we are given a tree like this one and our goal is to find the summation of the deepest leaves. For example, in this tree we have 3 leaves, 7, 5 and 8, but we are going to return 15 because 15 is the summation of 7 and 8 and we only consider the deepest leaves. So we are not going to consider 5. We only consider 7 and 8. Okay, let's start writing the code. So the first thing that we are going to do is to define the tree that we just talked. So for doing that, we have a class node. Input is value, that is the value of the node, and we could have a left and right. By default, those are none. And here I define the tree, and we have 4 heights, 0, 1, 2, 3. As we are going to use BFS, the first thing that we are going to do is to import DQ. So I can say from collections import DQ. Then I can define a queue and say Q equals DQ. And also I'm going to initialize the height as h equals 0. And I'm also going to return a value at the end that is the summation of these leaf nodes. I mean the deepest leaf nodes, and we are going to return a variable. We can call it sum, and I can initialize that as 0 at the beginning. Okay. I also need to initialize my queue with the first value of the root. So how can I do that? So let me put queue here. We can do this. We can say q.append root and 0 because our height is 0. So you can also initialize q at the same time that you are defining that. If you want to do that in only one line, you can do it like this. So this is the exact same thing as having these 2 lines. Just make sure that you're using these brackets. So for example, if you don't do that and just do this one, you are gonna get an error. Just a side note. Okay, that's not very important. Now the next things that I'm gonna do is to start a while loop. While q, I'm gonna pop left from q and call that node and current depths. Node and current depths equals q dot pop left. Okay, when we pop left a node from Q, this node, 2 things could happen. The first thing is that that node is a leaf node and doesn't have any children. So we could say if node dot left is none and node dot right is none, in that case we can consider that in our summations. But for now, let's leave that and consider the other situation. Else, it means that that node has some children. So for example, I'm at node 2, I have 4 and 5. So in that case, I'm gonna add them to my queue. That's just easy. So we say if node.left, it means that node.left is not noun, that exists. I just add that to my queue and say q append node.left and current depths plus 1. The reason that we are adding this one is this. For example, I'm at node 2 and I want to add its children. So 4 and 5. We know those are in a 1 deeper level. So when I'm adding that to my queue, so I need to plus 1 here. That is similar for node right. If node dot right, again q dot append node dot right and current depths plus 1. Now we should consider the situation that we are at a leaf node here. In this situation, again 2 things could happen. For example, consider the leaf node 7 here. So I already observed 1 leaf 5 and imagine that is part inside saved in my summation. But at leaf 7, I'm not gonna add 7 to 5 because 7 is at a new level. at edge 3. So in that case, I should initialize a new summation and say, okay, any other summation that happened before this level, we are going to ignore that. For example, I had a summation here 5. That was my leaf. But when I'm at 7, I'm going to ignore that. I'm going to start a new summation. So I'm going to say if current depth is greater than edge, something that happened here, 7, current depth of that is 3. That is higher than my edge. Edge is 2 here. If that's the case, I'm going to start a new summation and say my summation equals node.value. So I'm going to add 7 to my summation. The next thing that I'm going to do is to update the edge. Edge equals current depth. Edge here is updated as the depth of node 7. So edge turns to 3. And as the result, when I'm at node 8, I know, okay, 7 is at 3 is the previous one that is observed. So the next situation is the time that our current depth equals to edge. Like here, I added 7 and now I'm at 8. 8 has the exact same height. So in that case, we say else if current depth, which is 3 for 8, equals edge. Edge is now 3 too because we turned edge to 3 in this line. In that case, I'm just going to add 8 to the summation and say summation plus equals node.value. Okay, now we have the solution. Let's run it. And we get 15 as the summation of the deepest leaves. Okay, to see a little more details about the algorithm, so I just put some print functions, and also I added one Q print that is replicate what Q does, just to have a nicer format of printing that, because if I just try to print the Q itself, it has a root and it's going to be a little messy. So that is not going to do anything, the Q print, so that is going to be deleted at the end. Now we just have that to print out some middle steps. Okay, if we run the function, we get the output on the right side. Let's go over that. Okay, let's consider the tree. At the beginning, I have root 1. That root 1 is added to my queue. Root 1 here, and the current depth is 0. Then I pop left this element from the queue. That is node 1 and current depth 0. And edge is 0. Now I have Q as this one. I have 2 added and 3 added because these are the children of my node 1. If you remember here in the code, we have node left added and node right added. Okay, so we add these 2 and 3. Now this is my new queue. Again, I pop left, node 2, depth 1. I'm at node 2, I add 4 and 5. 4 and 5 are added to my queue. Pop left 3. Right is added. 6, 2 is added. We pop left node 4. What is added? Node 7. Node 7 is added with the depth 3. Now I'm going to pop left 5, 2. I'm at node 5. Node 5 is a leaf node. So there is no children. And depth is 2. Up to now, I didn't observe any leaves nodes to update the edge. Edge is still 0. And I'm at leaf 5. And because edge is 0 and current depth is 2, I'm saying, okay, this is a new thing. I'm going to add that to my summation. So I start a new summation, add 5 to that, and update the edge. Now edge is 2. It means that at height 2, 1 leaf is observed. What is my queue now? The queue is 6273. So I go pop left the node 6. I'm at node 6. I can add node 8. Node 8 is added. Now we pop left node 7. Node 7, what is that? That is a leaf node. Okay, what is the edge? Edge is 2. We already had a leaf node at the level 2. While I'm right now at the level 3. The current depth is 3. It means that I have to start a new summation. So for 7, I'm starting a new summation. and add 7 to that. And I update edge to 3. What is my queue now? 8. Okay, let's pop left 8. I pop left 8 with current depth 3. And I look at edge. Edge is 3 because we updated that when we were at 7. Now, I'm not gonna start a new summation. I'm gonna add 8 to the current summation. So I update the summation to 15. What is my queue now? Empty. There is no node left in the queue. So that is the end of the while loop. And I'm going to return the summation, which is 15. The time complexity of this problem is order of n because we are using BFS and we are observing each node only once. The space complexity is also order of n because of creating that queue that we have, and the size of that queue will never be more than the number of nodes in the tree. As a result, the space complexity is also order of n. Okay, this is the solution of the problem deepest leaves sum, and thank you so much again for watching this video.